So like I've actually so before I was living in San Francisco, sometimes found these occasionally there, but I was very surprised to actually see them.
Yeah.
But normally there's like regular club latte, which I'm not actually a fan of, but the winter one, which is like spice syrup, it's like a little, it's like a little cinnamony.
You're drinking pumpkin spice club mate, Will.
Essentially that, to be honest.
You're so basic. I love it. That's hilarious. We are live. Will and I are talking about his beverage of choice, Club Mate, which I didn't realize until I started working for Parity is like a kind of an iconic Berliner beverage. If you'll enjoy my purposeful American mispronunciation there. Do people say Berliner in Berlin? How do people from Berlin refer to themselves?
I haven't been here long enough to actually appreciate that, but I would say Berliner is quite common from what I've
Oh, is it? Okay.
Yeah.
Have you ever heard that story about JFK when he went to Berlin?
No.
He said "Ich bin ein Berliner," which I think more correctly translates to "I am a donut." A Berliner is like a type of donut, and so it's kind of certainly within my family, kind of a running joke. But yeah, we are here to talk more about funny stuff associated with Berlin. This is a Substrate seminar. This is a weekly recurring web seminar, conference, learning group where we get together and learn about Substrate, which is a framework for building blockchains for the Polkadot ecosystem, curated by Parity Technologies, which is the open source software company that both Will and I work for. And I'm Dan. I'm a developer advocate. I'm usually the host of seminar. And today, Will is joining us. And as I was thinking about, hey, Joshie, what's up? As I was thinking about, kind of what we'll talk about, you may be one of the people who has a title that is both cooler and more ambiguous than mine, because people are always like, oh, developer advocate, that sounds cool. What is it? And so why don't you tell us what your title is and what you actually do?
Yeah. So hey guys, my name is Will. My role at Parity is the Master of Validators. And that's my actual job title, which is I find both hilarious and also it kind of doesn't make sense to anyone outside this blockchain space. But it's actually funny because it's actually on my passport. So if I'm ever traveling out of the country, it's going through customs and border patrol and whatnot. They read that, they always give you funny looks. So that's kind of funny. But okay, so what is this Master of Validators? Essentially, I work kind of both internally as well as externally. For helping people get up and running with infrastructure, running nodes, running validators, a bunch of things like that. But basically, I think this kind of boils down to okay, how do you actually kind of use these networks? How do you interact with them? How do you kind of get up and running with some of the infrastructure and the puzzle pieces to actually kind of both support as well as interact with and kind of actually run these things? So. This includes both kind of Kusama and Polkadot built with Substrate, as well as all the kind of projects that are building on Substrate that may or may not connect to Polkadot or Kusama, just because they're all kind of cut from this same cloth. So basically here to talk about how to get up and running with some of these things, some considerations around securities, some things around kind of what to actually do when you go from maybe developing these things to actually putting them into production. Either in a testnet, an incentivized testnet, a canary net, a production main chain, kind of all of the above. So,
awesome. That's really cool. Yeah. So I think, that's a great overview of what we're going to talk about today. As Will kind of even indicated there, building a blockchain and more than just building a blockchain, running a blockchain. It's a big effort and it requires multi-disciplines, many people doing many different types of things and thinking in many different ways. And so as Will and I were kind of chatting before we started and talking, Will was the stuff that you think about doing, it's completely different than what I do. So mostly what I've been learning about for the past 8 or so months is, writing a blockchain, the business logic of a blockchain. And that's really hard and important. And there's a lot to learn about when it comes to that. But then once you've gotten the blockchain written, you have to actually run it and maintain it and make sure that the people who have the money invested in it at the very least, don't lose money, and ideally maybe make a little, and that the people who rely on that blockchain for the services it provides are having a good experience. And so that's a lot of what Will does. And so, as we talk to people all throughout the ecosystem, we're learning about, the questions that people have. And another thing that I mentioned to Will as we were preparing is I love to hear our builders teams asking these forward-thinking questions. How do I make sure that this network that I'm building is secure, not just like functional, but actually secure and robust and resilient and all of these kinds of things? And that's what Will does. That's the kind of stuff that I don't know much about right now. So we're all going to learn about that together over the next several minutes, however we have however long, all morning for me. So yeah, I do see that there's already a few questions coming in the troll box. I just want to remind people on Crowdcast, there's the Ask a Question button down there kind of along the bottom. And if you have a question that you'd like to ask Will about his presentation today, please use that. I'll kind of be emceeing questions. Will just told you kind of what he does for Parity, and we just kind of went over what we're going to be talking about today. So let's try to ask questions related to those things, and I'll be moderating the questions in those ways. So yeah, I see that there's a couple questions in the what I like to call the troll box there. Please keep chatting. I love it. I'll be chatting in there. Let's see. There's one question already. I kind of remember a tool, although not sure. I think this may be a leading question. Will, do you know what Shevdor is talking about here?
Wait, he just edited it. So a tool you can use against your server validator to run some type of auto test, some type of Substrate nmap. I don't know. At least okay. I'm not exactly familiar with any tools that kind of do that specifically. Maybe I know there was like this thing called like Hafa or something like that, which maybe somewhat-ish similar, which is more so for kind of like writing unit tests for doing external extrinsics, as far as I know. Besides that, I'm not entirely sure. So sorry.
Okay. Yeah. Sorry, Shevdor. Since you write so many tools, at first before you edited your question, I thought maybe you were like asking a leading question about something that you wrote. But yeah, if that's something that you saw and you end up finding it, please let me know, and we'll put it on my on the Substrate Awesome list. So let's see. There was a question here. Please tell how to list a new project with Polkadot. Any other way that you would list any other project, where we don't curate lists of projects, so that your marketing team can list your project. And I mean, I do think that there's like on our users, there's like the Substrate user showcase. That's all open source. So just make a PR and let us know the details of your project if you'd like to get that listed. Can you suggest about Substrate how to deploy with code? I mean, I think that we're going to be talking about that today. Will, that's going to be something that you go over. Okay, cool. So I think we covered the basics, and that's all I got. So Will, I'm going to hand it over to you now, and I think you have a little presentation.
Yeah. So let me share my screen here.
I'm going to turn off my video, but you'll hear me unmute my mic if there are questions or anything.
Yep. All right. So this looks fine and whatnot, right? So it says secure and substrate networks.
Yep, looks perfect, very clear.
So basically you want to talk about a couple of kind of different considerations and factors of how to actually kind of run networks, how to interact with networks, say even kind of beyond that. So say even if you're just kind of like interacting with both like Kusama, Polkadot, or any kind of like substrate-based chain, there's kind of like a lot of common factors here that are kind of applicable. And yeah, I already kind of gave an intro about myself, but Will, I am the master of validators at Parity, essentially kind of working on a lot of like external infrastructure related things, like helping people get up and running with their like validators, their nodes, wallet exchanges, integrations, kind of whole gamut of a bunch of things like that. So first thing that kind of just want to touch on is like keys. So based on the fact that like blockchains and kind of cryptocurrency all is very much rooted in cryptography and the fact that there's kind of keys, both like public, private keys, and kind of like how and where these things actually kind of like fit into the picture of substrate chains in general. So I would kind of separate this out into maybe like 3 broad categories. So there's like network keys, there's account keys, and then there's like session keys. And gonna touch on kind of like each of these, but it's mostly kind of like network keys and session keys that mostly relate to actually like running nodes, operating nodes, whether they're like full nodes or like archive nodes or like the kind of nodes that you actually kind of run for doing things like block explorers or wallets or exchanges or that kind of thing, or running like collator nodes or different other kinds of like parachain nodes, or even kind of like relay chain validators for Polkadot and Kusama. And then kind of like account keys are this kind of like shared type of keys that you use to interact with like any of these blockchains whatsoever. And so kind of first, just to kind of like talk about network keys, kind of like what they are, what they do. This mainly kind of applies to when you're actually kind of like running different nodes in any of these networks. So if you're building kind of things with Substrate, the idea here that you're trying to solve is like, how do I actually like identify peers and send messages? And how do I actually kind of like identify nodes and deal with kind of all this like peer-to-peer networking of sorts? And a lot of this is just rooted in the fact that Substrate uses a lot of the protocol labs-based kind of components here. So first and foremost is libp2p. This is the networking protocol that all of kind of Substrate uses for actually kind of like exchanging messages, talking from one peer to another peer, so on and so forth. And kind of like a subset of that is actually using multi-format. So multi-formats is this kind of other, I don't know if product is the right word, but product that Protocol Labs has kind of been developing, where you have kind of different formats for different things. And in particular here is kind of like the networking formats of sorts, of how like nodes actually kind of like interact with each other and actually kind of like talk to each other. And so the main kind of thing here that's kind of important is the fact that nodes that are substrate based kind of use multi-addresses, which are these self-describing network addresses. So these are used in kind of like every kind of node, whether you're running kind of like a validator node, a collator node, archive node, a prune node, like any node kind of whatsoever that's running in these peer-to-peer networks. They will use multi-addresses for actually kind of like identifying each other, for connecting to each other, so on and so forth. And so, okay, like what is a multi-address? So these are kind of these like self-describing addresses that are, it describes actually like how you actually connect to and talk to each other and kind of like what you're actually kind of doing here. So these are kind of like some of the generic examples from the website that are kind of just like the idea of how you actually kind of like go from one multi-address to kind of like another multi-address maybe. So they're kind of like self-describing. So they usually kind of start with whatever kind of like networking protocol that they're using. So maybe like IP4, IP6, DNS, so on and so forth. So you could kind of like imagine, compared to the regular way that like websites work, or a lot of other kind of just like classical networking things work, you'll typically just go to like google.com. The actual like IP that you ping to actually do this is like one of like a ton. You don't actually kind of know where things go to, so on and so forth. These are kind of just, at least multi-addresses are ways for a lot of peer-to-peer networking to specify how to actually reach things and how to actually kind of like find what you're kind of looking for.
Will, can I kind of just chime in with some of my conceptualizations and thoughts? So it sounds like there's a couple different ways that we're using these keys in Substrate and in the networking and stuff, but right now you're talking about kind of one usage, which is used for identification, right? Is that fair to say? And so this is kind of similar to like how we typically use like public-private key pairs. Like I think kind of what you're talking about, like with Google, like certificates and stuff like that. It's a way of establishing trust that's kind of rooted in cryptography. So it basically, you establish like this identity because you're saying like, I assume that the person who controls the private part of this key pair hasn't leaked it to anyone, and so they are the only person in custody of that private key. And so therefore, if I receive a message signed by that private key, I can therefore trust that it came from this one singular entity in charge of that private key. And now when we talk about an address in this instance, is the address the public part of that key, or is it something different?
Yeah, so it is derived from the public key of this. So you can kind of be assured that if you are connecting to something that kind of contains the representation of that public key, that like anything that you receive from them or you communicate with them, they are in control of that private key that's kind of corresponding to that. So this also kind of like helps with this kind of like secure type of communication with each other, to actually be kind of like assured that like who you're talking to is actually like who they say they are. So
right. So is that what the multi-address is kind of a way of taking the same public key and representing it in different ways?
So that's kind of part of it, but I would also kind of say it's, as I kind of mentioned, it's like self-describing. So it also kind of like includes the parts of how to actually like reach that person with that kind of public-private key. So it's like saying, hey, I want to talk over like UDP, I want to talk over TCP. It kind of like establishes the actual kind of like routes and means of communication of how you actually like establish and go about that communication.
Right. I see what you mean, because each one of these examples that you've shared, they contain like multiple paths. They get more and more specific with each separator. Okay, cool. This is very, very interesting. Thank you. That's all the questions I have for this time.
For sure. And to just kind of extrapolate on that then, Substrate, the way that these kind of keys themselves kind of work here is that you have kind of both typically, like if you're connecting to any kind of nodes, full nodes, archive nodes, etc., they're usually addressed by like IP4 addresses. So they usually will kind of start with like this kind of first section here, that's kind of like IP4 address, and then the actual kind of like IP address. And then typically all of these nodes also will connect over TCP, and the default port is 30333. So this is the peer-to-peer port, and this is kind of the port by which, like, if one node is talking to another node, they will send messages across this port here. And so then kind of this last part here is the kind of part that actually corresponds to how do you actually like identify people that are on this network at this IP address on this port. So this is where you actually kind of like derive, this isn't necessarily the public key directly, but this is a representation of the public key. So I think I may have a slide after this that says it, but like I believe you take the public key, which is a ED25519 key type, and then you take the base 58 address of that public key, and that's how you derive this kind of like 12D KOOW type thing here. For people that have kind of like been doing Substrate stuff for a while, they may recognize like there's this previous kind of representation of this, which was like QM something something something, which those are both like representations of the same public key, but you're just kind of doing different things on top of the actual public key address to kind of like make those representations. I'm not really sure why this new format is more desirable than the old format, but yeah. So in this kind of like second one right here, you specify 30335, and this is basically when you're running the node, you could specify the different ports and the different kind of things when you're actually doing this like with the command line. And so for this, you would kind of specify that because I don't want to use the default 30333 port, I want to listen and communicate on 30335, and that's kind of why this second one here is different. And then these last two, so these are actually boot nodes that I took straight from the Kusama chain spec. So going to talk about boot nodes a little bit later, but basically because boot nodes are kind of like more static entities, like you define these in the chain spec, and ideally you probably don't change the chain spec too often. You probably want to specify these kind of via DNS, just because you would have whatever kind of name here that you could like reach them at, and like behind the scenes, say you're actually kind of you have the rights to that domain, you could kind of swap the IPs kind of like in and out as you kind of want without actually having to update the chain spec. And so typically kind of substrate nodes are either addressed by like IP4 addresses or DNS addresses. And I would say like DNS addresses are like the main benefit there is boot nodes.
So Will, we actually have a question from Joshi on that exact topic, and I think you probably just answered it, but I think there may be room to clarify things a little bit. So Joshi says, why can the last two examples start with DNS? I thought it had to be DNS4, and I'm not sure if he means IP4 there, but it does say DNS4. So maybe Joshi can comment there. What exactly?
So I think that kind of goes to this previous.
I see. Yes, indeed. Okay.
So these were kind of these were examples ripped straight from the multi-formats, multi-address kind of spec in and of itself. I am not particularly sure why like there's no differentiation from DNS4 and DNS6, but that may be like a Pierre or Max question to ask, but. As far as I know, kind of just specifying DNS should more or less work for that. So.
Yeah, I was kind of laughing. Okay, so I'm going to go ahead and mark Josh's question done. I was laughing when you were talking about the format of the keys, you know, like you know that you're a nerd when you get like freaked out because the key starts with 1-2D and not QM, you know, whatever. Like it has, like I've been there, by the way, you know, it's happened to me. And then the other thing is kind of just like last week when I was talking about Rust syntax for Substrate, and like when you're doing a programming language, just like when you're talking in a natural language, like there's some things that you just have to accept, kind of like that's just the way the language is, you know, like at some point someone, you know, when we're talking about this kind of stuff, it's like a specification. Some person sits down and writes that specification and what it means. And invariably, when they do that, they make mistakes and they make stupid decisions, and their own, you know, messed up thoughts as a person leak into this specification. But that's the way it happens. And then I know, and this is kind of what I am hearing from you as well, is that for me, a big way that I maintain my sanity and allow me to like learn about new stuff is like if something feels like it's just part of the language, whether it's the network specification or the cryptography or whatever, I'm just like, great. Whoever wrote that probably did a better job than I ever could have. So I'm just going to go ahead and use that one. So yeah, we do have another question though from Alan. That's just my musings there. So it is about the multi-address. So let's see what he has to say. Does the multi-address used for boot nodes support not providing the port? Like, and then he provides an example without the port, using the default port in that case. The question is because it seems that parachain node implementation doesn't support specifying the public adder for the chain and the embedded relay chain.
So I believe you still will need to specify the defaults, or like even if you're using the default port, you will still need to specify that. Just because I am not entirely sure that like when you specify the multi-address, like say either in like the reserved peer and the boot nodes of the chain stack, so on and so forth. I don't believe it's actually determined as like a valid multi-address unless you actually specify those things, even if you're kind of just still using the default ports there.
Right.
So you'll still need to address it kind of the same way of like IP4/TCP/303.3.3/P2P/ like node key or whatever.
And that's like, I just want to expand on that a little bit and tell me if I'm getting things wrong here, but this is because we're talking about two distinct layers. The default values are Substrate decisions that people over in Substrate decided for, you know, what those parameter values would be if they weren't explicitly specified. And then as you and I just described, this multi-address format that we're talking about is a mechanism for unambiguously referring to some entity that could have chosen any combination of these path separators. And so multi-address has no knowledge of what Substrate defaults are. So Alan, if there is something that's not friendly about the interfaces for parachains, please let us know that, and we need to approach that as a separate problem because multi-address can't just know about Substrate defaults.
Exactly. And so like if you're kind of specifying, hey, I've actually changed my default port to like 30335 or something like that, like it won't really know like by default that things have changed. And so that's why you still kind of need to explicitly kind of mention that. So yeah, just to, I guess, kind of then continue on here. So kind of already talked about this, but there's each of these kind of sections describes the part that you actually want to do and explicitly kind of say that like what you kind of want to do. So you first kind of define like, okay, this is the IP4 address. I want to talk over TCP, and then I want to actually talk to this peer-to-peer node with like this identity. And also roughly kind of talked about this, but this kind of like long string of like 1D3 blah blah blah. This is like the base 58 address of the public key. And this is still kind of part of this multi-formats kind of specification. We're kind of using this off the shelf, but the way that we use this off the shelf is kind of like used in particular. So it's like this like 303 port, like we specified that, and kind of the combination of these different like chunks of this, we as kind of people that have been making Substrate have decided like, hey, this is the actual thing that we're going to use, and this is why all these things are chosen and required, and so on and so forth.
Will, I'm sorry. I know I've been kind of interrupting a lot. Story of my life. I'm sure you knew what you were getting into. I want to make sure that we don't gloss over this idea of base 58, because certainly when it comes to usability, and remember that usability directly relates to security, because the easier things are to use, the more easier it is to use them correctly. So can you talk about base 58 for a second, and why as a developer advocate I get so like jazzed up about it?
Yeah, so base 58, like this kind of way of actually like encoding things, I believe this like may have started with Bitcoin, may have not, but it's actually nice because there's nothing that's like ambiguous about it. So like I believe it doesn't reuse zeros. So if you see like an O, it's like properly an O. L's and capital I's, like you don't like mix those things up. And so the actual like spec itself for this is quite unambiguous. Like if you see letters, like they are hard to like mistake for other letters. So God forbid if you actually type these things out, like it's easier to not mess those up. So.
Exactly. So this, when a person was designing this encoding, they were thinking to themselves like, oh man, sometimes when I have to type these keys, these really, really important keys, they have zeros and uppercase O's, and I get really nervous typing these out. I don't know which is which. Wouldn't it be nice if there was another encoding that I could just know that if I saw something that looked like this, I knew what it was, you know, because the encoding doesn't use things that look like one another. And I do believe that base 58 came from the Bitcoin ecosystem. I shared the link to the wiki in the chat there. But yeah, just like quality is the sum of many small things done well. And the fact that, I don't know if we selected base 58 or libp2p selected base 58 and then we selected libp2p, or what it may have been, but like this one small thing is one of the many, many things that make Substrate and Polkadot relatively easy to use, relatively easy to secure. Okay, yep. That's my soapbox there. Thank you, Will.
For sure. And then to just kind of talk about how you actually derive those base 58 encoded like public keys, there's actually a couple of different ways to actually like specify those when you're running the node. So as I mentioned, these are ED2 519 public-private key pairs. And the way you actually like specify, hey, like I'm running a node, I want my node to use whatever private key to have it derive whatever address. There's kind of like two major ways for this. Like the first is when you're actually running the node, there's a flag that's like -- node key, and then you just input in kind of the private key for that. And so that should be like the hex encoded representation of the private key. This is like all right if you're running like dev chains or like local nodes or things like that. But like if you're actually running things kind of like in production, this is maybe not what you want to do, just because like it kind of gets saved to your like terminal history, and there's kind of some concerns about that. But this is kind of like a kind of quick and easy way of actually kind of specifying it with this flag here. But kind of the more standard way of doing this is either generating this yourself or letting the node actually generate this for you. So if you want to generate this yourself, you can do so with key. Like I believe this subkey was the name of it before, but I think this is now just being boiled down to key. But basically what this is a binary that also, I believe, ships with nodes itself. But this is used for both kind of like generating keys, inspecting keys, so on and so forth. Like this can be used for doing things on like an offline air-gapped machine if you want, or an online machine if you want. But generally, if you're generating keys isolated into themselves, like this is a pretty good way of actually going about doing that. And so you can generate this key yourself if you want, save it to the location that keys are generally stored, or if you don't actually want to do this, new keys are generated automatically if they don't already exist. So there's kind of this path that whenever you run nodes, they will go to, and I kind of like extrapolate this a little bit where it says like path to node, but generally this is like .local /share / like node name, or like the chain name / chain name / network, or something along those lines. And the key by default will be named secret ed25519. And so like in this file will be kind of the hacked representation of the private key, I believe. And so if you don't actually specify this at like startup, it'll automatically generate one. If you stop the node, start it, the file should persist. And so that file is generally what is used for actually determining what the public key representation is actually, like what is used as. And so generally it's like after this is created, there's not really any reason to create new network keys. Like these are just mostly used as like a one-time thing. And most people, like they don't even kind of need to actually pay attention to these things. Like the only kind of circumstances I would say that you probably need to pay attention to these is if you are running boot nodes and they have like a specific key that is specified in the chain spec. And so say you're like migrating one boot node from one server to another server. In that case, you should probably back up that network key and put it onto the new node. Otherwise, you have to like update this chain spec, which is kind of a bit annoying to do. And kind of this kind of just mentions that pretty much. So boot nodes always should have kind of the same network key, just because you can't really specify anything that's like too dynamic, at least kind of like in this current way of actually specifying like chain specs. And I guess kind of like the other perhaps situation you may want to change them though is that like if you have reason to believe that they are compromised on whatever node that you're running. So like say they are compromised by some way, shape, or form, there's not really anything that like the attacker can do only with this network key in and of itself. Like the worst case thing that would happen was like maybe some of the peer-to-peer networking like may not kind of work as it maybe should, but I believe it actually may still work, just because since this whole kind of like self-describing multi-address is saying like, hey, I'm at this IP address, I'm at this port, unless this other like attacker is using that same key on the same IP address on the same port, like I'm pretty sure it should still actually like work. But in the case that is kind of compromised, you should probably still create new ones anyways. But network keys in general like aren't the worst thing to worry about in the case of like, say those are compromised, so on and so forth. It's mostly just for kind of like usability. Say you run boot nodes, like that's kind of mainly the thing that you should kind of be attentive to actually kind of maintaining those is like a static thing. So then to kind of maybe move on, unless there's any kind of questions of some form about kind of like networking things.
We do have a question from Joshi. What happens if an active validator accidentally changes node keys while validating?
Sure. So as I understand things, like this network key is how you actually identify yourself in any of these protocols. So I'm going to take the assumption of like validator assumes like relay chain validator on Polkadot or Kusama. So there's this whole kind of like authority discovery protocol that is around how to actually identify who's like a validator in the network or who's like an authority, and how to reach them, how they actually kind of differentiate between which parachains to actually validate on, that kind of thing. So based on talking to Pierre, I think what will happen is that like if you change your node key, which will change your peer ID, what will happen is that like there will be probably like a 20 to 30 minute delay, which you can't actually validate on any parachains, just because this whole like authority discovery protocol needs to update things. This new information of like, hey, here's who I am and here's how to reach me needs to like propagate through the network, not just to the relay chain, but to all the parachain collators as well. And so things like should still work if you change these node keys, but there's probably a delay by which you won't actually be able to properly like validate these block from collators that may kind of like mess things up. So
yeah, I think that's a really good question, and I think another, like, correct me if I'm paraphrasing wrong, Will, but I think one way to answer the question could be undefined behavior. Right? Like, we don't know. You're not supposed to do that. It's an excellent question because it helps people understand like the types of things that you're not supposed to do. But again, I would say this is where we have to return to this idea kind of that I talked about a little bit at the last seminar, which this is systems programming. You know, we try very hard to create a robust system, but at some level, like, you're implementing a protocol at a system level, other things are depending upon this. There's many interacting parts that all need to be operated and maintained in the right way. And so that's exactly why we're having this discussion right now, because you need to understand, like, okay, these keys are really important. There needs to be like layers of protection around things like changing keys, for instance, because if that happens, the system will go down. And you as a system maintainer need to be aware of the fact that people are relying on you to keep the system up and running. So yeah, excellent question there. Any other thoughts before I close out the question, Will?
I would just say kind of like a lot of the assumptions with networking and this whole like authority discovery protocol make the assumption that like node keys will remain static. And that's kind of like why there may be this like undefined behavior, kind of like it won't get you like slashed or things like that, but like things may just like stop working for a little bit until it kind of comes back to normalization, as far as I know. But still a bit of an unknown, and you should probably not change keys unless like you really need to.
And please, if you want to find out on a private test net. Okay, done answering. Thank you, Will.
Okay, so kind of the next section here to talk about is basically account keys. So here's all the different things that you interact, or like how you interact with the network. So all like the primitives of like, hey, I have a wallet, I have like funds in this wallet, I want to participate in setting a transaction, participating in governance, staking. Say I have some chain that like mints tokens, like, and I'm a minter and I want to actually do those transactions. Say I want to get like a tattoo in the Kusama Society or something like that, and I need to send a transaction to bid for my tattoo or whatever it is, you know. These are all the keys that you interact with the network with. And they're actually like, there's a lot more differentiation here than compared to like other networks. So I guess maybe to start and talk about some maybe context, just to differentiate between like different kinds of keys. There's kind of like hot keys, there's warm keys, and there's cold keys. So these terms are like not like super explicitly defined per se, but there's a general idea of how to kind of separate these. And I would say kind of like hot keys are these ones that are they're stored on the touch machines that are actually connected to the internet, and they do transactions quite often. So these are the ones that maybe sort of like MetaMask, for example, or they're just like actively used quite often. And so generally, like these keys should not hold like a ton of funds on them. They are a lot easier to compromise. Like these keys kind of in and of themselves are, they should be thought of almost as like ephemeral or like disposable or maybe even like temporary, without kind of like any additional kind of like layers on top of it. And so hotkeys, they kind of like have their place, but they should be used with the context that it's a lot easier to actually like compromise these. So kind of like know when you're using hotkeys and kind of take a lot of the considerations kind of appropriately. As kind of a next kind of step here, I use cookie emojis just because cookies are best warm. But basically, like warm keys are similar to hotkeys, but they have kind of like an extra layer of some sort to actually differentiate them, where they're either like stored on hardware that's maybe the hardware is kind of used a lot, or they're like maybe like a multi-sig, or they kind of like have some restrictions where even if these keys are compromised, it's not like the worst thing ever. It may be the case where it's like, say you have maybe like a proxy account, and we'll talk about proxies a little bit, but it's like the compromise of this key in and of itself may not result in the complete loss of funds for whatever is actually kind of holding the funds. But like warm keys are kind of this compromise between actually like storing things in like a hot manner and like a cold manner. And so cold keys are these keys that should ideally kind of be stored on either like paper or maybe like an offline air-gapped device. They may do transactions, but if they do so, it's probably like pretty rare. And like even if they do transactions, they should be done on like an offline air-gapped device. You should like create the transaction on that offline air-gapped device, do the signing and the signatures all on that, transfer that to an online device, and then kind of send it from there. Generally, like cold keys are the least compromisable, just because it may be like even just a physical representation of these keys, you need to like physically compromise things to actually kind of result in like a theft of funds or something like that. So cold keys are like the most secure, hot keys are the least secure, and there's kind of ways to actually do both at once in this kind of like layered approach, and that's kind of what I'm going to be talking about here to actually do. So when actually using keys in this kind of Substrate ecosystem, there's a lot of like primitives that you can use to kind of like pick and choose and combine these things, kind of like Lego pieces almost. And so these are kind of like normal or stash accounts, controller accounts, multi-sig accounts, I think it's a multi-sig accounts, proxy accounts, anonymous proxies, and time delay proxies. So these are all kind of like primitives that you can use to kind of like layer things together to create this actually like really nice like key structure. And like the context of when you would use these are, say you're like a foundation and you're launching a new chain or something like that. Say your chain has like a token. The way to actually like custody the tokens for your new chain and to actually like do things in a pretty secure manner is like you would create these kind of structures of like layering things. And this goes for like if you're like maybe launching a new chain, or say you're running like a validator or like a collator, or something that even just kind of like you need funds secured in a pretty decently secure way, but you also want to like interact with things on chain quite often. So this also comes into play like if you're doing things with governance, or if you're like getting like treasury proposals, or like any of the above really. And so to just kind of like walk through kind of each of these, where they fit into this, and kind of the pros and cons of them. That's kind of what's next here. So to talk about like account keys, these are maybe referred to as like normal or like stash accounts, and these can do anything, which is good and bad. So you can do pretty much like any kind of transaction on the network that you're running. You could do like a transfer transaction, a governance transaction, staking, whatever even the individual specific kind of transactions for your substrate-based chain is. These can do any of that. And kind of because of that, they're like the least secure, and they should probably not be used by themselves for anything really important, just because like it's kind of like a single point of failure with where if this key is compromised, you lose everything. You lose access to funds. You lose access to whatever kind of transactions or extrinsics that you want. And so if you do use these keys, they should be done on like an offline air-gapped device. These should ideally be cold keys if these are used in isolation. The kind of caveat to this, though, is like account keys these kind of standard ones in and of themselves. These can be used in this like layered approach to kind of create better structures. So the next kind of a key here is like controller keys. So these I would say are actually almost like a legacy type of key at this point, just because this was almost like the first iteration of what we were making, where it's kind of like you want to actually kind of do almost like role-based access control around what you want to do. So controller keys can only do staking-based actions, at least kind of like by default for Substrate, Polkadot, Kusama, etc. So this was the idea that like, okay, you have maybe like a stash account, you keep this like offline, you never really touch that, you set the controller account, and only the controller account then can do staking-based transactions. And this is good for a lot of cases, but I would say this is like superseded by the notion of like proxy accounts and almost kind of like more like fine-grained controls there. So controller accounts, I would say, are good and they kind of like have their place, but I would say eventually they may actually be removed, and like proxy accounts are kind of like a better way of actually doing things. So this is 2 slides in one, I suppose. But to touch on multisig accounts are kind of a better way of actually doing things compared to like a regular account, where you can have M of n signatures, where M is the threshold and N is the total amount of people. And so this is good, but also has a bunch of drawbacks that are kind of better fine-grained with some of the additional additions that I'll talk about in a second. But these kind of require coordination between like however many parties that you have that are comprising this multi-sig account, and it requires like deposits for all the transactions. So say I want to, I have like a 2 of 3 multi-sig, and I want to do some transaction of some sort. Requires 2 of the signing parties to actually come together. The first one proposes the transaction, the second one approves the transaction. The UI UX is not like amazing for this so far, but it works and it's usable. And so these are kind of like just a better way of doing things that requires multiple people than like one account. So if you're like a governance participant, or you're doing like a treasury proposal or something like that, having like a multi-sig account that actually participates in things, that's kind of like a better primitive in and of itself. But it does get better with some of these other things that we'll kind of touch upon also in a second.
Will, can I kind of chime in here? We have some questions.
Sure.
And then also just want to mention, some of y'all may have seen the article on Decrypt about the rebranding of Polkadot. And we are using all of these things that Will is talking about to help facilitate, this on-chain funding of the rebrand, and not just funding, but I think really like the management, the administration of the rebrand. And so we are, as I like to say, drinking our own champagne here. Maybe right now we're drinking more like Prosecco or something like that. But as we drink this and we realize like, oh, this is not quite so friendly, it'll get better over time. So like we're doing this, we're in it with y'all. So I just think that's really cool. I'm like super into this whole rebranding thing. And Will, I see you maybe doing some work over there. If you're getting the link, that would be awesome. But I can also get that. But I do have some questions here, and so I can get the link if you want to do the questions. Rodolfo wants to know, can I use an HSM UB key, for example, with a validator out of the box? There you go. Okay.
So well, I can touch on what I just linked a second, but yes and no. So like the kinds of account keys that we use are both SR2519 and ED25519. And UB keys, as they are HSMs, are these ED25519 keys. Like just using kind of those keys themselves will work for signing transactions, but I'm not aware of something that is actually translating the thing from hardware to the thing from software. So I know there is kind of this entire suite of things that people kind of have been working on called Armistice, which this is a lot of kind of what the people in the Cosmos ecosystem have been working on, where the whole idea of this is to be able to use very secure like hardware devices for actually signing things, in particular this like USB Armory device, which it supports like more than just these ED255 keys. It supports like BLS, so on and so forth. So I am hoping in the near future that like using YubiKeys for that is actually doable, but currently it doesn't exist. So I believe like people are like looking into this and kind of working on it, but this current point in time, I would say no.
Yeah, that's really cool and a really great question. Okay, let's see. We have some others here. Also, a couple good questions. Is offline transaction signing available to keep the private stash keys on the air-gapped machine? And I think I can go ahead and take this one. And Will, please correct me if I'm wrong. But I would say that the answer to that is definitely yes. And in fact, I shared a link to a seminar where we demonstrate some of this. It's the seminar number 23 in the troll box up there, seminar about hot wallet architecture. And so this we demonstrate using tools like TX Wrapper and Sidecar. Yep. Will shared another link there. There's a whole suite of tools that can be used for offline transaction signing. So not only is it possible, but we create and maintain tools and workflows to support offline transaction signing because it's a vitally important part of these security measures that we're talking about. So excellent question. Anything to add there, Will?
No, I'd say that's it. Like there's a lot of different approaches to actually doing that. So some of those links there are good places to look into.
Cool. And then the last question here. Am I right that session key has 5 seeds? Why is there 5 seeds in a validator in key store directory?
So that I'm actually going to touch upon after these account keys that I'm going to talk about. So
awesome. I'll leave that question for later. Awesome. Thank you, Will. I'm going to turn it back over to you.
Sure. So then besides kind of multi-sig accounts, then kind of want to talk about these proxy accounts. So proxy accounts are more of a new addition compared to the other ones. And they actually kind of create a lot of interesting functionality there. So basically the way that this works kind of like from like a substrate level that you're actually coding and making things with, you basically kind of specify a bunch of these like call filters. So basically say you have like the staking palette or whatever, you could then create a staking proxy that kind of, if you specify an account as a staking proxy, you can only do the calls that are listed in that palette, for example. And so this is kind of similar to the controller account, but almost for a more like granular basis of specifying what kind of access it actually has to do for the proxied account. So it's a bit of a confusing terminology there, but like you have an account and you specify a proxy account. So the account that you specified it with is called a proxied with the D account, and then the new account is the proxy account. And I have some diagrams here that kind of explain this, but basically you say you have like this like stash account here, and you kind of specify this new proxy account. Both of these accounts are of the same kind of type of this like regular account that I first mentioned when talking about accounts here. So they can kind of do anything in and of themselves that relate to itself. But if you specify a proxy account for like this kind of stash account here, this proxied account can, depending on what type of proxy it is, it can do any action on behalf of the stash account. So to make this a little bit more clear, there's kind of a bunch of different kinds of proxy accounts here. And I think this may get a little bit cut off, but just describe the last one. So you have like an any account, which this is as good as kind of the regular account in and of itself. It can do any transactions whatsoever. It actually kind of specifying in any proxy doesn't really give you much in terms of like security. It's not actually as good as like segregating access to things. So this like any proxy could add new proxies. It could do like transfers. It's not really great in and of itself, but there are some uses for that, and I will also talk about this in a second. But the kind of benefits you get from these proxy accounts, though, is specifying different kinds of proxies. So, for example, using like a governance proxy, this account can only then do kind of governance-related transactions. So, say you're like a foundation or something like that, and you have a bunch of funds that you kind of control as a foundation. You could then kind of specify, say, like a governance proxy where people that have access to this can only then do kind of governance-related transactions on behalf of those funds that are owned by the foundation. They can't do any transfers, they can't do any staking things, and so kind of limiting control there is actually creates a lot of like useful properties. And kind of similarly for these staking-related proxies, they can only then do staking-related transactions as well. There's also a registrar-related identity kind of proxy, and this is mostly used for like identity things. So Shavdor, maybe like you have a proxy for this kind of thing, like that's pretty useful. But that's the idea there is just kind of separating things out there. The last one listed there is a cancellation proxy, which this actually kind of doesn't currently exist, and this only kind of currently relates to time delay proxies. But the idea there is that this account can cancel announced transactions on behalf of when there's like a time delay. So we'll also touch on that in a little bit. But the idea here is just that you have a bunch of different kinds of proxies that you can specify for different things. And when you're like building a substrate-based chain, like depending on like what the chain actually is and what you're actually doing, you can create these kind of proxy types yourself. So say, for example, like you're a stable coin, or you're making like a stable coin, and there needs to be like a person to actually do a transaction that actually like mints new coins. You can kind of create like a minting proxy, for example, where this person can only do minting-based transactions, for example. And so say you're like Tether or TBTC or whatever it is, like that kind of thing. You could give specific control to specific people or groups of people based on those actions in and of itself. And like these are kind of just good primitives where you can like layer things together and kind of create these key structures that are quite nice. And I would say the core kind of like value that is driving these is that given any single key that is compromised, you can't do any harm. It's kind of like things together in these kind of like structures, the combination of things that kind of gain access. And so that's kind of like where I would say the benefits of these things come from. And so the following slides, I think, kind of illustrate these in a better kind of visual way. So let's say, for example, you have like a stash account. So say maybe you're like a validator, like a VC fund or something like that, and you own just like a bunch of tokens in this stash account. If you create these like individual kinds of proxies, these kind of give you good ways of actually like separating out the concerns of access. So if you create like a staking proxy here, this can only do staking related transactions, and you could only you could give this access to someone on your team that's like a person that's super interested in governance, for example. And they can't do transactions, they can't do staking things. Because their sole role is like just solely focused on governance, they can only do governance transactions, and it's good. So similarly for maybe like the staking proxy, say you have some like DevOps people on your team, and their sole role is dedicated to running nodes. Their access control then can only be for submitting validate transactions, like setting session keys, setting commission, a bunch of things like that. And so this kind of gives you a little bit more like fine-grained control over how you actually specify accounts. And like this picture here is all right, but the power really kind of comes from when you like combine a bunch of things. So for example, here you could have like a multisig account where you have these different like bag holders that like, say this may be like a foundation, say you're a chain that just launched a token or whatever. You have maybe like the C-level people that all own access to this multisig, and only kind of together can they do transactions. But you could then specify separate people on your team that are maybe they're a governance person or maybe they're like a staking person. They have access to those funds to actually do their like operational work. So basically the benefits here are that you gain this kind of like operational access with things, but you don't actually kind of have the access. To rephrase this, I guess, like the 2 of 3 multisig, this would be more so like a cold wallet. You may not actually do transactions from this wallet in and of itself often. You could have this on paper. You only really need to specify those accounts as proxies maybe like once, and you don't have to touch this multisig again if you really want to. These like governance and staking proxies, they may be either like warm or hot accounts. And so actually like compromising those is not good, but at the same time, you could just remove those proxies from the access there, and no one can do transactions. So this kind of creates some better properties there compared to, so you just have like a regular account and you just do everything from that one account.
Will, can I chime in with some thoughts and a question from Joshi as well? So one of the things I shared a link there in the troll box to the Wikipedia article for the principle of least privilege, which is this very important idea in security that any given identity should have access to the minimal number of resources necessary in order for them to do their job. And so what Will is describing here is a very important way of architecting a system that adheres to the principle of least privilege, where you can create facets of one identity or something. When you start thinking about this kind of stuff, it becomes very meta, very philosophical, how you represent identity and roles and all that kind of stuff. It really gets into like software design and systems design, and it's super interesting. So I think it actually kind of dovetails directly now into Joshi's question, which is, can palette authors introduce new proxy types that make sense for their palette?
So I believe this is actually specified in the runtime itself. So for example, for Polkadot and Kusama, this is specified in the runtime there, where you create the new kinds of proxy types, and you specify the call filters of like what palettes that you want to include. So to me, this is like not as much of my wheelhouse of actually doing kind of substrate development, but you specify in the runtime, as far as I understand, and you can kind of create new proxy types that are specific to your purposes for your chain. So
yeah.
As I gave the example earlier, if you're doing like a stable coin and you have like a minting thing, you can create like a new proxy type where their sole purpose is like maybe just one function, which is like a minting function or something like that. And so I believe that's where you would specify that.
I believe that you are correct. I haven't worked as much with proxies as I would have liked, but just based on my knowledge of Substrate and what I do know about these proxy types, it's an enum in Rust code. They materialize as an enum. And I think of them abstractly in my mind a lot like origins. And so I think just like a palette can define custom origins, I think a palette could define custom proxy types. And just to kind of like tie all these things together, in a palette, you define new types of capabilities. You define new types of privileges. And so it's very reasonable to think that you would need to define a new proxy type to help maintain this principle of least privilege. So short answer to that question is yes, Joshi. Great question. We do have another question here. How do I create a proxied account? Does it have a private key or just an address? How do I designate its proxies?
Sure. So whenever you have like a regular account, so this is like the same type of account, so you just like make a new account using whatever UI, say like Polkadot.js apps page or whatever. I would call this like a regular account, sort of. So you would then send an extrinsic that I believe there's an option for this by default for most things in this Polkadot.js apps page. In the account page, the 3-dot menu to the right, there's an option that's called like add proxies. So you could either do that there or from like this extrinsics tab where you could just specify the extrinsic for any palette whatsoever, but it would be like proxy.add_proxy. And so from there, you would specify the new account that you want to set as a proxy, and then like the proxy type, and then the time delay. So the time delay part, I'm also going to talk about in a little bit, but you specify any account there as the proxy, like any account as the proxy. And so then generally, like in most cases, you would specify another like regular account. So this would be another account that has like a public private key, but you can also specify like a multisig account, any kind of account that has like a corresponding public address. And this kind of maybe foreshadows some other stuff that I'm going to talk about in a little bit, but not every account that you set as a proxy necessarily has to have a private key, but most like regular accounts that you create and do have a corresponding private key. So like, for example, a multi-sig account, those don't have corresponding private keys. They have kind of like this sharded access of the 2 of 3, for example, members, but that doesn't have like a corresponding private key. So it depends on what account that you're setting as the proxy, but you could set any kind of account that has a public address as a proxy.
Yep. Just to add a little color there, I think, as Will has kind of mentioned, like a lot of this stuff is just defined in the runtime. There are capabilities that are defined in the runtime. There are, of course, APIs to interact with them. But certainly for the purposes of this discussion, I think the most important thing is to focus on like, what is the capability of the account type, not so much the implementation or like how you work with it. We're more talking about like high level. Will has used this term primitives a bunch of times. Like, what are the different primitives and how do they fit together and why do they fit together? That's really the most important thing to focus on. And I know it can be difficult to always keep that straight. So, I mean, great question, but just helping to draw the lines here. We have another question, Will. Oh, it's from Sveta. What's unused type of proxy?
So this, like, you may come across this if you're interacting with like Polkadot or Kusama. I believe like when the enums were specified, this is some legacy code of the pseudo type. So like when that existed, you could set like pseudo as like a proxy type, but since that was removed, that will just show up as like unused now. And that's not going to show up unless you also create a new chain that you add pseudo back into it. So.
Awesome. Thank you. All right, back to you, Will.
Gotcha. So, yeah, you could also, it's not just the case where you specify maybe like one proxy. So say you have this like multisig here and you specify like a governance proxy. Like that governance proxy can have a proxy in and of itself. So you can like layer these things to a pretty absurd level, to be honest. So this is like another kind of example maybe of maybe something that people want to do. So for example, say you have like 3 bag holders that are a part of a multisig. You can set like access for maybe like a staking proxy and a governance proxy for this multisig. And then you could set one entity as the person that can interact on behalf of either of those like governance proxies or the staking proxy. So like in this case, this multisig, you would need 2 or 3 people to actually do any transfers or any kind of like transaction that's related to anything that's not either governance or staking related. But you could set like only one member of the multisig to be like in any proxy of the governance and staking part of this. So this bag holder 1 in this case, they can do any governance and or staking related transactions on behalf of the multisig, but they can't do any transfers. So this can be nice if you have maybe like C-level people on your chain that you're doing, and you want to give them like very specific access control to like very specific things. You can kind of layer things in this case in this type of way. It then kind of goes one layer deeper and a bit wonkier. So with the addition of these things called like anonymous proxy accounts. So like when these are actually named anonymous proxies, it's maybe a bit of a misnomer where the fact is like not actually anonymous. So don't like do anything related to assuming that these are anonymous, like launder money or something. Like that's not really what Polkadot is useful for. Is like Substrate is useful for at the moment. So hold off on that. But basically, what an anonymous proxy account is a keyless account that the account that you create it from is the one that you control it with. So it kind of gets a little bit confusing at this point, just because, like, as I mentioned earlier, there's this like relationship of regular account to proxy account. So when you specify this new account as the proxy account, you control this regular account like from the proxy account. So say you want to do like a staking transaction on behalf of the regular account, you do and approve this with this like new proxy account, for example. But it kind of flips this relationship when you create the anonymous proxy. And so because of that, like say you remove all the proxies from this regular account, you lose access to this anonymous proxy. So I would say kind of be careful there. And there's some poor images in a sec that kind of help, I guess, explains a little bit better. But this new kind of like proxy account is actually quite useful just because there's no private key to it. So like you can't compromise an account that has like no private key. The only thing that you can compromise is like the account that you have like that accesses that new account. So this kind of creates this new useful primitive where you kind of like say you want to retire an account that has access to something. You could just switch the access from this one account that accesses this anonymous proxy to a new account and then remove this old account. So this is probably better just described with images here. So here, as I kind of mentioned, it almost like reverses the relationship here, where if you have like a regular account that sets a new account as like a proxy account, you give this proxy account the ability to control the regular account. But this relationship is kind of switched with kind of this anonymous proxy, where the regular account that you create the anonymous proxy with, you control the anonymous proxy from this like regular account. And so this is kind of because there's no private key, there's no way to actually like access this new account. So you're delegating the control of it to any other account that kind of creates it, but then you can kind of set it under kind of different circumstances. So I guess I'm just going to kind of stop there maybe and see if there's any way to, any like questions or maybe a way that I could clarify that a little bit further.
I don't see any questions, and if I'm honest with you, I was kind of like catching up on some notifications in the background there, so I don't have any questions of my own. I did share the link to the issue that I believe you created, Will, for renaming anonymous proxies, which I think is very, very good. Yep, Dan Shields is sharing some great comments and resources there, but no questions, so I think we can assume that people are with us.
Okay, so as I mentioned, like these things in and of themselves, I would say are primitives. So you can better kind of combine these things into better things that are bigger than the sum of its parts. So as an example, like say you have this like multi-sig account, you like in the case of, for example, you have like a foundation, say you're launching a chain and has like a bunch of tokens or whatever. In this case, it's useful to actually store the funds on the anonymous proxy account, just because, as I mentioned, it has like no private key that can be compromised. The access in this case would be done from this multi-sig account. So in order to do anything with these foundations funds, in order to do any like transfers or anything like that, you have to do like a 2 of 3 multi-sig transaction. And the only way for any of this foundation's funds to be compromised, you would have to compromise like 2 of the 3 multisig shard holders in this case. So it kind of creates these better structures of actually like storing funds, restricting access, kind of so on and so forth.
Yep. Joshy chimed in the troll box. He said that he's with us. So I think, just to kind of like, tie some more of this together, one of the resources that Dan Shields shared was this awesome article about using a hot wallet architecture. And it really describes like one way that these primitives can be combined. But just to kind of like say things in different ways, in some ways you can kind of imagine that we're talking about like a type of programming language for making things secure, So you think like in a programming language, you have things like numbers and lists and, Boolean values and all these different things. And so in Substrate, you have all different types of accounts. You have proxy accounts and anonymous proxies and time delay proxies and multisigs and, and they can be layered and mixed and matched. And it can be thought of, abstractly as like a Turing complete security language that you can kind of let your mind go crazy and compose these things in a way that solves your problem securely. But if you've ever studied security, by kind of definition and by kind of necessity, they're very subtle, very nuanced topics, and they're not always easy to explain quickly. You kind of really have to get into that mindset of thinking like a security person. But I think the really important takeaway from my point of view is just that these primitives exist and that there are examples that you can see of composing them in different ways to create really secure, robust systems.
Exactly. So just kind of to even expand on kind of how to combine these things in useful ways, using multisigs, as I kind of mentioned before, there's some like drawbacks to it, like in and of itself. So for example, when you create this multisig, you specify it with like a threshold and amount of members. So say it's like a 2 or 3 multisig. You can't actually change that after you create it, which is not as useful as you may think. So for example, if you're like building a substrate chain, you have like a company or whatever, and you specify like the C-level people as owners of this multisig, like things happen, people leave, like people move on and work other jobs or whatnot, and so you may have to like remove access to things, or you may have to change things up every so often. And so that kind of doesn't give you a lot of flexibility in and of itself. And so the benefit here of using these kind of like anonymous proxies is that you actually kind of like can change things. It's actually like pretty flexible and pretty dynamic. And so the idea here would be that like you start with the image here where you have say like a 2 or 3 multisig, and this is kind of like your starting point. And say you want to change it from like a 2 or 3 multisig to like a 2 or 4 multisig. Like say someone joins, you want to give them access there as well. And also keep in mind like the funds for your foundation or your chain or whatever are stored in the anonymous proxy still. It's the multisig that has access or can like approve access to any transaction or whatever. So in this case, you would set it. This image also kind of gets cut off a little bit, but at the bottom here, there's a new account there. There's 4 members, and this is like a 2 or 4 multisig. But what you would do is from the 2 or 3 multisig, you would set the new 2 or 4 multisig as any proxy of the anonymous proxy. So you're basically giving access from this anonymous proxy to another account at this point. And so any of the 2 of the 4 multisig people in this new kind of account could then approve any transaction, so on and so forth. And then kind of from that, you would then remove the access from the original multisig so that this new multisig that's like 2 or 4 people, they have then control of all of the funds from this anonymous proxy. And so as I kind of mentioned when I first started talking about these anonymous proxies, is that you want to be careful of not, for example, removing access to this first multisig before you set the second one. Because in that case, then like no account can actually control this anonymous proxy, and it's kind of just like floating away in isolation. So like, you have to do like a sept and layered approach, but allows you to actually be able to have a pretty flexible way of actually having access to some account of some way, shape, or form. So an example of like when this would be used, for example, is I believe Dan linked this, but like for example, the brand refresh for Polkadot is also done via this. So this is like a multi-sig between a couple different people from like Parity, from Moonbeam, from other projects as well. And this is all behind an anonymous proxy, just because like maybe some point in the future, like one of the members of that multi-sig may do something else, or maybe you want to add members like that. You can actually change the composition of those multi-sigs that give you access to the anonymous proxy in that case. And that kind of gives you a lot more flexibility, a lot more ways to like dynamically use and interact with like funds or that kind of thing. So just to kind of talk about like another primitive here is the idea of like time delay proxies. So these are actually not really like a separate type of proxy, but like a layer on top of any of the proxies that I've been talking about before. So whenever you create a new proxy, like one thing that you would specify is a time delay when you create it. So you could specify the amount of blocks that it takes for the transaction to actually like execute. So say I want to set like a staking proxy or a governance proxy or any kind of like proxy like that. You would specify the time delay when you create the proxy to be either like 0, being that the transaction executes immediately, or say like 100, where the transaction would execute after 100 blocks. And so this gives you this kind of like time delay by which you could actually cancel the transaction if it's between this time period of you like announcing the transaction and this 100 blocks. So to talk about maybe like the security implications of this, this gives you a means of actually like say you have a staking proxy or whatever it is, and this does all like staking transactions. It like nominates, it validates anything related to staking. You can have some type of like monitoring on the account that watches for transactions. So you can like look to see that, hey, maybe this account like sent a nominate transaction that I didn't do, that I wasn't expecting. That can probably indicate that the account was compromised somehow. So you can be able to cancel that transaction then, and it gives you a way to actually be notified if you have monitoring for these things, to see that like some type of compromise may have occurred. Just because there's a time delay, you can cancel anything that's like in that kind of buffer. So this is kind of a layer on top of that. It gives you like a little bit more time to actually be able to cancel things. Like say, for example, even you have a bunch of people on your team and you give access to a bunch of things. Maybe that person like left the company and they still have access to stuff, but they execute a transaction that you probably like don't want to happen, but like there's a time delay on it. You can actually like cancel it. So that gives you some nice properties there as well. So this maybe is an idea of putting this all together into like more of a layered approach here. As I mentioned, you could have these like multisigs that are part of the anonymous proxy. This anonymous proxy being the account that actually controls the funds for things. So say like you're on a team, maybe like you're launching a chain, you have a foundation or whatever it is. You can control the funds all in this account that like no single person has access to. You can delegate access for only like transfers for like a 2 of 3 people of multisig. Say they're like C-level people, say they're the founder of the company, something like that. And then so you have like operational people that are a part of like the DevOps team, or maybe they're interested in governance or something like that. You could give them access to like the staking or the governance or the staking parts of those funds via like multisigs or even like additional proxies. And so like the power of all this kind of really comes from when you're combining like all of these primitives into one big approach, sort of. And like for most people, like this may not be as useful if you're like a single entity, but the power of this kind of really comes from like when you're like a team, you're working with multiple people, you want to like segregate off access to things, kind of so on and so forth. Actually combining these things is kind of where a lot of this power kind of comes from. And as kind of I mentioned, some of the, kind of the key principles of like having this interesting kind of key structure in this layered approach is that you want to like segregate access as much as possible, just so that like if one thing is compromised, it doesn't like ruin everything. So even in this kind of example here, like the only kind of case where if one thing is compromised, it may result in bad things is like the 1 of 3 gov multisig. So if one of those people kind of defects or like they go rogue or something like that, in that case, like they can do transactions that other people may not want. But if it's like a time delay proxy, any of those other shard holders can cancel those transactions. And in that case, you could just revoke access to this 1 of 3 gov multisig and state a new multisig, and that person like loses access. So it's the idea that like you want to limit as much as possible of kind of like single points of failure in kind of like key structures that are like compromising that kind of thing. And then second part of this, I would say it's like using multisigs with anonymous proxies makes both like way better. You're able to like dynamically adjust them. It's more flexible. It's just a better approach to doing that. And then lastly, it's just kind of like separating out the concerns with the appropriate kind of key type. So depending on what kind of chain you're making, what kind of chain you're using, making the appropriate kinds of proxies for what's useful in that case is nice, and kind of like giving the appropriate access to either like people on your team, people that you're working with, or like users of your chain. That's probably the best case way of actually kind of like creating just more usable things for people in general. And I haven't really seen other like blockchains do similar things where it's kind of like a base level primitive of the chain itself, giving you like this kind of like granular access. It's like the only kinds of things that you can do with this are like if you're working with Ethereum and you're making like a smart contract based wallet. Like those are the only kinds of places that, as far as I know, that you can create these types of like role-based access controls of wallets and whatnot. So in this sense, like Substrate is super powerful for the security of actually like storing funds, of being a custodian, all that kind of stuff. So next portion, I would talk about session keys, but maybe just going to stop there and see if there's questions.
We do have a question. Actually, I'm sorry. There was a question, but I think I'm going to defer it because it doesn't seem directly related to what we're talking about now. And I do want to make sure that I give you the time to cover things. So seems like we're getting great feedback. And as far as I can tell, people are with you and they're engaged and asking good questions.
Cool. So I guess next section to talk about is session keys, which these are pretty much only for if you're doing like operational things. So if you're running a validator or like a collator, that's kind of where these kinds of things kind of come in. And although they're based on the same kinds of like public-private key types, so either like ED25519 or SR25519, these have very little in relation to the account key types that I've just talked about earlier. So these are actually a lot more similar to those like network key types, but we'll kind of explain some of these. So the ones listed here are more so specific to Kusama and Polkadot at the moment, but these are available also as primitives in the palettes for if you're building your own chain, so you want to have like similar types of ideas of maybe like liveness that you use heartbeats for, or maybe like authority discovery or things along those lines. But these are the 5 key types that are stored on relay chain validator nodes. So there's the I'm online key, which this is used for sending heartbeats and is determining liveness. So heartbeats, for people that are not familiar, if your node does not produce a block within a session, so a session being an hour on Kusama or like 4 hours on Polkadot, or however many time blinks you want in whatever chain that you're building, if it does not produce a block in that time period, it will rely on a heartbeat to determine if the node is like online or offline or not. So generally this will happen around like 60 to 70% of the way through the session. And at that point in time, it will send a heartbeat. So for anyone that like uses the Polkadot.js apps page, if you're looking at like validators in the list, there's a little like envelope icon to the left of a validator if it has sent a heartbeat. And usually this will only show up around 50 to 60% of the way through like a session. And then there's Babe keys, which are slashable, but this is used for block production. For people that are building substrate chains, like you can use like Babe or Aura or maybe even proof of work for kind of block production. But in the general case for using like Babe off the shelf, for example, that is a slashable key. So there is some considerations to be done for that. And similarly for Grandpa, that is also a slashable key, but this is more so used for like the relay chain and is used for block finalization. So if you're creating a substrate chain and you don't plan on connecting to a relay chain, like say you want to make just like a sovereign chain in and of itself, like you may have Grandpa just for finalizing things, but if you're connecting as a parachain to the relay chain, or maybe like a parathread, for example, you probably won't have Grandpa keys. And this is also a slashable key. Then there's like authority discovery, and so this is for a bunch of like networking shenanigans where most people probably don't like need to deal with this. This is kind of like one of those things that's like under the hood that you don't really have to like fiddle with or implement yourself or kind of like extend or anything. But this is mainly for actually determining like who in the network is a validator, who is a collator, what is their identity, that kind of thing. This is a non-slashable key, so that's nice. And then for relay chain validators for like Polkadot, Kusama, or any other relay chain, there's this parachain ID key, which is a slashable key, but this is used to sign like the validity statements of parachain blocks. And as I mentioned, this is a slashable key. And slashing is not fun, so there's some considerations there that you should always generate new keys. You should never copy keys over to a second server. Like the #1 reason why people have been slashed on Polkadot and Kusama is because they've had session keys in more than one place at once. So generally, like you should never ever like copy things over. So say you have like a validator node, you're setting up like a second server, you want to start like at some type of like block height, and you think you're smart and you kind of like copy over the database of like one node to another node. Pay very close attention because the key store folder and the database folder are like right next to each other. And if you copy over the key store folder that contains these session keys, you will double sign and get slashed. So that's the main reason why people have been slashed so far. There's been maybe like, I think maybe 10 cases of this in the past like month or two alone. So it's actually more common than people think, but session keys should never be copied over. Always iterate new session keys and pay very close attention to creating or like copying over like a database or like a backup of a database or that kind of thing. And we'll also kind of touch on that in a second. But next section here is just talking about like infrastructure, the kinds of infrastructure needed for setting up nodes and that kind of thing. So kind of just a list of things is that like you have like boot nodes, like relay chain validators, parachain collators, full nodes, which are mostly used for like wallets or exchanges or that kind of thing, RPC nodes, block explorers, and like a telemetry server. So to start off, we're talking about boot nodes. So okay, like what are boot nodes? Boot nodes are these nodes that you specify in the chain spec, and because like you specify this in the chain spec, when the chain spec is packaged up with every node that anyone runs. So if you're like making your Substrate chain and people are running like full nodes or collator nodes or whatnot, that chain spec is included in the binary, and so it for sure will have this list of nodes. And so the purpose of the boot node is this is usually the first node that this new node that you're starting to run, this is the first thing that it will connect to. And its purpose is mostly to like bootstrap peers in the network, just to know like, okay, I'm starting a new node. Who should I connect to for peers? Like who's a good other node to talk to? So generally, like when you're running things in these peer-to-peer networks, there's kind of this like shared repository of all the nodes in the network that's mostly had by nodes that are like already running. And this is called like the DHT or like the distributed hash table, which there's also like Kademlia stuff there and whatnot, but basically like nodes will know who is currently on the network by making entries into this this hash table, and it kind of knows like who is currently active, who's not active, maybe who's a new person to talk to, kind of from this like shared list of people. So if you're starting a new node, it won't have context of any of these like whatsoever, and so it will need to talk to the boot nodes to actually know, okay, like after I started this node, who should I talk to from here? And so this is like used to kind of bootstrap peers and kind of continue on from there. And so kind of because of that, these boot nodes will need to pretty much like always be running. And it's probably good to host like 4 to 6 of these if you're starting a new network. The kind of alternative, and so like this is maybe how like Substrate-based stuff kind of differentiates from Cosmos. Cosmos doesn't have boot nodes, which is just a different design choice, but like sometimes what people have to do there is like ping somebody on Telegram or something to be like, hey, what's a node that I can start to connect to? And so they have to kind of manually almost do this like off chain and go from there. And so that's kind of the role and the purpose of what boot nodes are kind of like for. And so some kind of considerations for boot nodes. One is that they have to have like a static IP address that you can kind of talk to. And as I mentioned before with kind of specifying things in this chain spec that are kind of like addressable by things, that's kind of like why you may want to define these as like a DNS name instead of like just a static IP address. So for example, say I'm starting a network that's called, I don't know, like a cookie network or something like that. So it's like cookie.network/bootnodes or something along those lines. You would specify the IP address like that resolves at that DNS name, just because say you want to like switch out peers, but you don't want to, or you want to switch out this node that's at like a different IP address, but you don't want to change and update the boot node. You would just replace that under the hood, change the DNS records, and this new node kind of points the new node is pointed to from that DNS name, and you would have to update it with the same the network key, but it should still work there. And so that's why you would like address this with DNS in the chain spec. When you're creating these nodes, the only thing that you really have to kind of pay attention to is like peer-to-peer traffic. And so you just pretty much want to open up this peer-to-peer port, and you could close off like all of the RPC ports. Like there's no real reason why boot nodes would need to kind of have any like publicly addressable RPC calls like whatsoever there. And like say you're running maybe like 4 or 6 of these, you probably want to specify all of the nodes that you're running as reserved peers. And you also will want to run these on in some place that has like a limited bandwidth. So for example, maybe like a bare metal server in some providers will offer kind of like unlimited bandwidth for those things. And you probably want that just because the cost of doing this in the cloud, maybe like GCP or Azure or something like that, like the actual ingress and egress kind of bills to pay for that can be a bit high. That's why you may want to just do this on like a bare metal server with limited bandwidth. And you also will want to specify like a high amount of peers for these. So that is that. We actually just kind of did a migration of boot nodes for Polkadot and Kusama, which was actually not too bad, but kind of was involved in that recently, so that was kind of interesting to see. But maybe we'll stop there and see if there's any questions about boot nodes or other things.
Yes, there are questions. And also, I should mention, I do have a hard stop at the top of the hour. I have another meeting at the top of the hour, so unfortunately, I need to make that known. But let's go through the questions here and see what we have about boot nodes, because there are some. So the first one is from Dan Shields, and Dan asks, can you set a Tor onion service for boot nodes and other nodes on the chain spec?
I believe like currently no, but it's actually, I think actually pretty possible. And that may be something that we want to do in the future. But this is like one of those things that kind of boils down to libp2p and how you specify things. So for example, instead of like specifying like IP4 or DNS or whatever, you can imagine maybe like Tor being the actual like the routing layer that you want to kind of specify there. And I know a lot of like the Web3 researchers are pretty keen on like torrents and Tor and a bunch of those other awesome peer-to-peer technologies. And so I can imagine a future where those are actually specified. So
yes, love it. Okay, good question, Dan. We have a question from Joshi about boot nodes. Is it possible or advisable to use validators or collators as boot nodes?
So it is possible, yes, but I would actually recommend to not use those as boot nodes. And I will talk about this a little bit more in a second in talking about kind of like the chain spec stuff. But the reason why you probably don't want to do that is just because generally like these boot nodes are nodes that everybody talks to. So like if you're a validator, like your main concern is maybe like being like slashed or being offline or that kind of thing. And so like you may not want to talk to like everybody. And like everybody like may include like malicious nodes per se. So it's possible, but like you may want to kind of like separate access out for like validators or collators. And there's literally like a section in the chain spec that you would specify like the other validators that you want to like start a chain with. So say you're like starting as like a POA chain, you would specify the session keys of these additional validators that you want to run there. So I would say like yes, but probably not something you want to do.
Good question. All right, let's see. Are there any, here's a question from Art. Are there any best practices regarding securing boot nodes, validators, collators, now that we can't use sentries? For example, proxies or firewalls?
Yeah, so I also will kind of touch on this maybe a little bit more in a second, but for boot nodes in particular, these are like, I guess the main thing to think about is how, like, what's the worst case scenario of like actually compromising these? And so for boot nodes, there's actually like not a lot of bad things that can happen. The worst thing that can happen, I guess, is like new nodes in the network. If all of the boot nodes kind of go down, is that like someone can't, or someone may have like a hard time actually connecting to the chain and finding new peers and whatnot. And that can kind of be like ameliorated by like someone just specifying a new peer or like a new boot node in the command line itself. And so for boot nodes, I would say kind of like the main thing to kind of pay attention to is setting up firewalls around everything but like the peer-to-peer ports that you specify. So by default, like 30333. So block like all traffic besides the peer-to-peer traffic. And like you may want a proxy in front of it, you may not. Like when I was kind of helping set up the new ones for Polkadot and Kusama recently, we actually we tried this with like a Cloudflare proxy in front of the boot node, but it didn't work well, so we removed it. So I would say it may take some kind of finagling there, and depending on what kind of like proxy you may want there. But for boot nodes, I would say like it's not super entirely necessary to have like things in front of it, so long as you kind of firewall off everything but the peer-to-peer ports.
Awesome. And bonus points for the use of the excellent SAT word ameliorate, which I shared the definition for in the troll box because I was so enthused by it. So there are a couple of other topics that feel a little off, a couple other questions that feel a little off topic to me. So I'm going to go ahead and let you carry on and reserve those for a little bit later.
So yeah, to then just touch on like relay chain validators. So this is like where I probably spend most of my time with, but there's kind of a couple of different considerations here. One, like the first thing here is actually a consequence of removing sentry nodes. So prior to this, like the idea was that you could have a public, or like you'd have a validator that sits on like a private subnet or something like that that's not accessible by the public. And you would have the sentry node in front of it. That sentry node is like publicly addressable, is like a public IP address, and you could have this validator sit in like a private network and not do anything that's any like public whatsoever, really. Like the sentry nodes would be these things that talk to like anything that's public facing. But about a few months ago, we kind of decided to somewhat like temporarily remove sentry node. Like sentry nodes may pop up in the future, but the main issue with them was that actually like routing things with sentry nodes was a bit of a pain. It's mostly like the routing of collator nodes to validator nodes on the relay chain. So for example, imagine like we have sentries. The idea would be that you route from the collator to collator like through the sentry node to the validator that's assigned to that pair chain. And the issue kind of comes from the fact that like sentry nodes were able to be sentries for multiple different validator nodes. So you could have maybe like 3 different sentry nodes that sit in front of 5 different validator nodes. So you would have to like route to whatever like public facing sentry node, and then from there determine like which of these 5 validators is the one that's actually assigned to this parachain. And like the actual kind of like this multi-hop steps like networking sub-protocol shenanigans was a lot more complicated than we wanted to figure out at the moment. And so we kind of made the decision to just remove sentry nodes altogether in favor of having like all nodes just be kind of like publicly accessible and that have like a public IP address. And so this is maybe hopefully going to be a temporary thing. Like sentry nodes kind of may come back after there's some more designing around the networking protocols of these things. But for now, they're removed. But the idea there is that you would then have some type of like layer 4 TCP proxy in front of it. So say maybe like Nginx that can help filter things. It's not like the best case scenario there, but it kind of just adds some additional like layers between the rest of this public internet and like your also public internet facing validator net. But going back to maybe like the kind of key things, so basically you have to associate your session keys with some type of like on-chain stash address, and that's kind of like where a lot of the benefits of like those account key types that I mentioned earlier kind of come into play. You want to kind of like have a bit of like segregation between who has access to the actual like operational concerns of maybe setting session keys, maybe setting commission, setting the validate transaction, maybe like nominating validators from the actual like source of funds itself. And to reiterate myself a lot, like don't ever copy over session keys. That will get you slashed and you will lose money and people will be salty about it. So there's that. And also like kind of be careful with like backing things up. So like while it is kind of possible and it works to kind of like create these snapshots of the DB folder. So the use case is like, say you want to start a new node. The alternative is just like syncing from scratch. But if you have like one of these database folders, you could just kind of like copy this in and start the chain from where that database kind of currently is, which maybe pretty recent, and so you could start the chain from like, I don't know, maybe like 100 blocks ago, and it will continue on fine. But what a lot of people do is they copy over the entire like chains folder that includes the key store, and their session keys are in more than one place at once, so they get slashed. And so you want to, if you do backups this way, you only want to copy over this like database folder. And so you should be pretty cautious about actually doing any of that. Pretty easy way to get slashed. So besides that, like in terms of kind of like RPC ports and things like that, generally, like there's a lot of different kinds of calls that you could do via RPC. So for example, you can like rotate session keys. You could actually like add peers and maybe like remove peers with RPC calls. You could do a bunch of things like that, which are generally like not super safe. And so there's literally this flag in the client that will be like unsafe RPC calls, some variation of that. And if you enable that, it should only enable that like to localhost. And so if you use this in combination with this other flag that's called like RPC external, you'll expose this to like anyone on the public internet. And so they could like rotate your keys. They could do a bunch of other shenanigans. And so you basically, if you do expose unsafe RPC calls, you should never do that also with this like RPC external kind of filter also on. Just because like if you're running validator, you will need to rotate keys, and that is an unsafe RPC call. And so you will need to use that at some point in time. But these should always be done from localhost. In that case, you should always have a firewall also to kind of block any RPC port access. So by default, I believe it's like 9933 for HTTP calls and 9944 for WebSocket calls. So generally, like blocking those two ports externally is good. And you may like to do that otherwise, like either have some type of like VPN to kind of map like hosts like locally, or just like SSH into the node to actually make those calls from localhost. And so generally that's some good ways to kind of like separate out access there. And also, as I mentioned kind of above, having some type of like layer 4 TCP proxy like Nginx in front of the node can also kind of help separate things off there. And then lastly, so this is like not really something that either exists or is super feasible at the moment, but like one way that you could kind of replicate this idea of Sentry nodes is that you have like a dynamic firewall to include only all of the other like relay chain validators and collators. So like this isn't currently exposed by any calls at the moment, so you can't like query stuff for this, but you can imagine like a RPC call in the future that kind of exposes all of the multi-addresses of all of the current relay chain validators in the set. And the idea here is that like if some other validator is currently in the validator set, like they probably don't have an incentive to be malicious or like hack you or attack you or that kind of things, because they also have things to lose. So you could adjust your firewall rules to only include all those other nodes because they are kind of in the same position as you. They are probably not malicious in that sense. And so then kind of like the only people that have access to your node kind of via networking is like all the other like relay chain validators or collators. So like have an issue open up somewhere that kind of like adds a call for this for the authority discovery module, but that's like a thing that's kind of TBD, I guess. And then just to talk about like parachain collators, these are very much similar to relay chain validators and kind of the concerns as well. So these also have to have like a public static IP address, also set like an Nginx L4 proxy in front of it, never expose public RPC ports. Depending on like what your chain is and like how you specify things. So maybe you're using Babe, maybe you're not using Babe. Maybe you have like specific session keys that are very specific to your chain. Considerations around like slashing are pretty similar, I would say, compared to like relay chain validators. And lastly, kind of like there's also this idea of like a dynamic firewall that I mentioned that kind of like you could only then include other parachain validators, other parachain collators, that kind of thing. Maybe we'll stop there if there's any relevant questions.
Yes, there are questions, and I do believe that some of them seem on topic. Well, Actually, I think we can defer most of them. Joshy just wanted to know if you can share your slides.
Yeah, I will do that now.
Okay, cool. Thank you. Yeah, and so then I think the other questions can be deferred, so that you can, continue to make progress on your slides.
Gotcha. There's not much more, but just one thing to kind of touch on here is like starting a chain and doing things in this like chain spec. And as I kind of mentioned, like this is how you would like specify a lot of things. So these examples are from Polkadot and Kusama, but like if you're starting your own chain, it'll be pretty similar. So like here are all the boot nodes that are listed for Kusama at the moment. This past 2 weeks, we actually just added a bunch that's like p2p.0.kusama.network. So that was a bit of a fun excursion of sorts. Generally, like if you define boot nodes, you should probably do it by DNS address. It'll still probably work with IP4 addresses. And if you like do things slightly differently, where you define separate peer-to-peer ports, or like for example, the first ones, these are 30100. This is something that's like not default, and so that was like manually specified. So if you do anything just a little bit different like that, you have to kind of account for that. Then also there's kind of like telemetry stuff that you can specify in here. Like if you want your own telemetry, you can specify it as whatever like URL that you want there. So by default, it will all go to this telemetry.polkadot.io site. And if you go to there, there's like a billion nodes for like every network whatsoever. But if, for example, you maybe want something particular to your own chain, so you want like a separate domain for whatever, you could also specify that. And you can specify like multiple ones there. So that can be pretty useful. If you also look at the chain spec, for a lot of things, it's just a giant blob of zeros and ones and hex values and stuff. So like it's not super discernible. Like this is the raw chain spec, so that's kind of why it's like not a lot of nice jargon and whatnot. But if you're kind of looking through the Polkadot and Kusama ones, like the things to perhaps probably pay attention to are, for example, this section where you would set like session keys. So this is kind of like how it was specified on Kusama, and because like the network launched quite a long time ago, these weren't done with like the best practices involved, but the network has since launched and moved on, and so these aren't as applicable to actually being useful. So as I kind of mentioned, it's probably best to separate out like validators from boot nodes, or at least like block producing nodes from boot nodes. And so you would specify this like with this like session kind of keys section here. So this this first address here is the stash address, and then you kind of specify the whatever session keys you have for your chain. So the part to like not do here is like reuse keys. So the Babe, I'm online, pair chain validator, and authority discovery, these are all the same, and you probably shouldn't use the same ones, but like when you start your chain, you should use like subkey to generate these individually, and then so long as you insert these on the node itself, like it should just like work. Just because like you specify your boot nodes, you point your validator nodes to the boot nodes, and because it has the keys that are in the local file system that are connected to that, like it will see that the chain spec has the keys listed there. It will see that it has the keys listed locally, and it will start signing blocks, hopefully. So that's kind of somewhat how that works. Polkadot is more so along the lines of like what you should do about using like just different keys, or like not reusing keys. So the first two addresses there, it's stash and controller. Like you may also want to use kind of different stashing and controller addresses, but like using the same ones may not be too bad. So that's kind of like how you would specify that there. And so basically, it's like you probably want to specify individual keys using key, or what was known as subkey, and then insert those via RPC. So there's like an RPC call called author_insert keys, and then you would specify the public address, the kind of key, and the mnemonic, or how you would specify it, like maybe the private key, depending on how it actually is. So that's kind of parts of the things there about specifying like session keys. And then when you're actually like launching a chain, there's a couple different like avenues by which you can do it. So you can set the initial validators as invulnerable, which means that they will never get slashed. So if they're down or if they're like they mess up, it's all right. They won't get slashed. It's kind of all right. Or you could transition from like a proof of authority, say using like Aura, to election based. And if you do it that way, it's like you probably don't want to force new eras, which if you force a new era, that will also trigger an election. So other nodes that are waiting as like validators or block producers or whatever, they will not actually transition from this current validators that you have of like hand-picked nodes to this new set. So it's like only after this chain is running pretty reliably for a bit, you may want to trigger this like first election. And so you will then like force the new era, it will trigger this new election, and then community nodes will then kind of be able to participate. Then lastly, there's kind of just two things here is like full nodes. These don't really have a lot of security implications. Like these can be compromised and it's like fine, it's not good, but like there's not really anything super awful that can happen to it. Like you can just spin up a new node and it's like probably fine. These will probably mostly want to expose RPC ports to the public, but you should also not enable any unsafe RPC calls because there's not really like a need for those. RPC nodes are like pretty similar there. So basically enable external RPC calls, but don't enable unsafe RPC calls. Also hosting these with unlimited traffic is probably pretty good. Load balance and endpoint, and then you could add this to this Polkadot.js repo, just so it gets like listed in that Polkadot.js apps page. If you ever see like a bunch of different chains there, that's kind of like where that's specified. Lastly, kind of block explorers and telemetry. Like you can host your own telemetry server, and that's only mostly really useful if you want things like super private to let people know that like these nodes, or you don't want other people to know that those nodes even exist really, because it kind of exposes IP addresses, and that's also kind of reasons why you want to have like good firewalling and maybe like TCP proxies and stuff. But that's mostly for these slides is like use those account keys smartly, like never copy session keys and restrict access accordingly. So thanks, and maybe if there's some questions here.
Yes, there are some more questions, and thank you. Well, that was really awesome. I know that's going to be very helpful information, and this is going to be a great resource for our community. So let's see if we can go through some of these questions here. I am going to start with the question from Joshi. He's wondering, can you tell us the basics of authority discovery or point to some docs? I want to understand the concept so I know what ports need to be exposed.
So to me, this is a lot of like black magic, and it's somewhat opaque. I would say digging through some of the code base that like Max and PR are kind of working on is like the best way to get a good understanding of that. But the TLDR is just like there's like HTTP ports, WebSocket ports, and like peer-to-peer ports, and those are mostly the only things that you need to either restrict or expose. And those don't really actually like touch authority discovery. Like authority discovery is very much one of those things in the background that hopefully just works. So.
Nice, and looks like we have at least one very happy customer with Joshi. He's giving us some good feedback there on the seminar today. So thank you, Josh. You're going to close out that question. Let's see some of these other questions. Here's one from Dan Shields. Would it be best practice to hide raw RPC nodes and proxy to these, or build services on top of it that are public, like Polkascan?
Yeah. So. It very much depends on kind of what you're doing. So if you're like building a wallet and you only want you only want like your services to access those RPC nodes, like in that case, then yes, like you can kind of hide that. You could use like certificates or a bunch of kind of like infrastructure related things to actually separate off access to that. And in that case, like maybe that's something you want to do, but that's more so if you're building like proprietary services and products and stuff like that. But generally, like there's a lot of different people that offer public RPC nodes that people can use if they're just like testing things out. But if you're building like any real like product or service that you want like only yourself to have access to, like you may want to actually have some type of like authentication on top of that or something along those lines. So,
yeah. Awesome. let's see, we have some other questions. Any thoughts for L4 TCP proxy with HA proxy?
Yes, that should probably work. Still a bit of like uncharted territory because I don't know if anyone's that's like made examples using that before. But if you want to look at an example of one that's kind of like already ready to use out of the box, there's kind of this Polkadot secure validator repo setup that this uses like a Nginx proxy here. So I'm just like this. But you can also use HA proxy for that, but it's a little bit of uncharted territory in terms of how to actually set that up. So.
Awesome. Okay, here's a question from Dan Shields. Can you and has someone already crafted Lightning Network payment channels with time delays in Substrate? Not the Bitcoin implementation second layer, but the base protocol.
I don't see why not. It would vastly depend on actually like Substrate specific implementations and stuff, but I could see that being used, so that would be cool.
Love it. And final question at this time, but if there's a few more, we can take them, although I do only have another couple of minutes here. This question is from Tomic. Off topic, but only a bit. Do you know how boot nodes are chosen in Bitcoin? Is it hard-coded?
I imagine it's also hard-coded, but that Stack Exchange link there probably describes it better than I can because I'm not 100% sure. But
Agreed.
It was done a similar way in Ethereum as well, where like it's also hard-coded. A lot of people that actually specify boot nodes in their protocols, it's usually all hard-coded. So.
Makes sense. Awesome. Well, from my point of view, we have finished right on time because it's now time for my next meeting. So Will, thank you so much for joining. This was, as I said, and as you can tell by the comments there, hugely valuable information for our community. And so this is going to make a great resource to have as a recording for builders teams, for them to review as they're preparing to go live and have this great this body of knowledge. So thank you so much for preparing this and presenting it and for the great conversation, as always, part of a seminar.
Cool. And yeah, thanks for having me. It's always been fun to watch these and good to finally be a guest on here. So.
All right. Awesome. Well, hopefully we'll see you again soon.
All right. Cheers.
Bye-bye.